Okay, let's talk about something most of us have experienced. You reach into the fridge, maybe for some bread, or you grab an apple, and bam, there it is.
Yeah.
That fuzzy patch of mold. What's your first reaction? Probably toss it, right?
Huh.
Straight in the bin. Most of us are pretty careful about that. But what if I told you that some of the real dangers from fungi aren't always the ones you can see. They're hidden, kind of insidious, and they can have truly devastating impacts. So yeah, this deep dive is all about that unseen world, mycotoxins.
Exactly. Mycotoxins, they're basically toxic chemical compounds. Fungi make them, especially those common molds we find in our food, animal feed, that sort of thing. And while, the visible mold is our usual cue to throw something out, the real danger can be these invisible compounds. They might have already spread through the food. Sometimes they even stay potent after cooking or processing. So today, drawing on the Fifth Kingdom, we're going to explore their history, which is long and often pretty horrifying, actually. We'll look at their effects on us and animals and how we've kind of learned to detect and manage them over time.
Right. So our mission today is to give you a really comprehensive, clear, and hopefully engaging understanding of these invisible assassins in our food. We want you to walk away with those like aha moments, understanding what these things are and why they matter so much without getting totally bogged down in dense scientific language. So let's start with the food itself. Grains, fruits, vegetables. A lot of what we eat is essentially non-living, natural, organic stuff. And that makes them just perfect targets for what scientists call saprobic fungi. These are the fungi that live on dead organic matter. They're nature's recyclers, basically. And that's why our food goes moldy, right? If we leave it out too long. It's funny how our reaction changes depending on where you live. In, say, Western countries, we tend to just toss moldy food, no second thoughts. But in some parts of the world, food's way too precious to waste like that. And then you have places like in the Far East where molds are actually used on purpose, to make fermented foods. Even here, we have things like blue cheese, which is, let's face it, moldy cheese we pay good money for because we like the taste.
That's a great point about perception. Because what we typically call moldy is often just the fuzzy stuff we see on the surface, the spores. But the real worry is what's happening underneath, these invisible thread-like things called assimilative hyphae. They can spread all through the food, and they're producing these secondary metabolites as they go. Those are the mycotoxins. They aren't strictly needed for the fungus to grow, but they're powerful chemicals, often alkaloids. We know of over 200 now, for more than 150 different fungi. And the key thing, the really crucial thing, is that they're toxic to animals and other microbes too, even at really, really low doses. Plus, they stick around. They're persistent. And often this is critical, they're heat stable, which means, yeah, cooking or sterilizing might kill the mold, but the toxin can still be there in the food, waiting.
Wow. Okay, so from that hidden nature, the history, though it gets genuinely terrifying. We've really only known about most mycotoxins since, the 1960s. But one condition, ergotism, has been plaguing humanity for thousands of years. Just imagine whole villages back in the Middle Ages struck down by this mysterious disease, limbs turning black, literally falling off, screams, terrifying hallucinations. They called it St. Anthony's fire. It was a fungal toxin shaping history for ages before we even knew what caused it. It was recorded as far back as the Spartans, 430 BCE. Chilling stuff.
Absolutely chilling. And we now know the fungal culprit behind it all. The victims had eaten grain, usually rye, that was contaminated with something called sclerotia. These are produced by the ergot fungus, Claviceps purpurea. Visually, these sclerotia, they're hard, dark, kind of purplish-black structures. They replace the actual green kernels and can look a bit like rodent droppings, actually. And inside these things is this potent cocktail of over 100 active compounds. But the real villains causing the disease are specific alkaloids, particular derivatives of lysergic acid.
The descriptions are just unreal. Ergotism showed up in two main ways. First, gangrenous ergotism. It would start with feeling tired, maybe some prickling sensations, really severe muscle pain. Then limbs would swell up, feel like they were burning, then go icy cold and numb. Eventually, feet, legs, they turn black, mummify. It led to this dry gangrene where fingers, toes, even whole hands or feet would just slough off. And then there was convulsive ergotism. This hit the central nervous system. Symptoms included formication, that horrible feeling like ants crawling into your skin, itching, numbness, twitching, escalating into these awful sustained convulsions. People might roll into a ball or arch backward rigidly. Brain damage was common. And the death rates were incredibly high, sometimes over 50%.
Yeah, it's horrific to think about. And even though the cause was actually figured out quite early, around 1673, widespread control measures weren't really put in place until a huge famine in 1770 led to massive epidemics. Even today, Claviceps still infects wild grasses, and sometimes grazing animals can still get ergotism. What's fascinating, though, is how the specific symptoms link directly back to the chemistry of those alkaloids.
Right. So these alkaloids, they do two main things. First, they affect muscles and blood vessels. They cause vasoconstriction, basically, narrowing the blood vessels, and that's what cuts off the circulation, leading directly to the gangrene we were just talking about. But here's the twist. We actually use this effect medically now. Like ergotamine tartrate is used for migraines because it narrows those blood vessels in the head. And ergometrine helps induce labor or control bleeding after childbirth. Then second, there's the effect on the central nervous system that's linked to lysergic acid elamides, and the most famous one, of course, is lysergic acid diethylamide, or LSD. It's an incredibly potent hallucinogen, known for, well, dazzling visuals, but also some pretty intense personality-dissolving experiences and unpredictable long-term effects. There's some potential for treating mental disorders, but it's definitely not something for casual experimentation. So it's just incredible. The same chemicals that caused centuries of suffering are now, tools in modern medicine. But how do we make sure we don't accidentally unleash St. Anthony's fire again in our food?
Well, today, ergot is actually grown deliberately for the pharmaceutical industry. They literally inject fungal spores into rye flours. But on the flip side, there are really strict controls to keep it out of grain meant for flour. Maximum limits are set. Those miraculous cures back at St. Anthony's shrine, they were probably just people getting away from the contaminated rye bread for a while. But yeah, modern incidents still happen. There was a case of a woman getting gangrene from an ergotamine overdose for migraines, and a farmer lost most of his pigs to ergot poisoning from contaminated feed. It's a stark reminder that Claviceps purpurea hasn't really lost its power.
Okay, so moving forward in time, our modern understanding of mycotoxins really took off in 1960. There was this mysterious outbreak in England. Tens of thousands of young turkeys, poults, suddenly started dying. They called it turkey X disease. They get sick, show these hemorrhages under the skin. And when they did postmortems, they found extensive liver necrosis, that's tissue death, and enlarged bile ducts. And similar things were happening in other birds, calves, pigs across Britain, too.
Yeah, and it was some really sharp detective work that finally cracked it. They traced the common link back to Brazilian peanut meal used in the animal feed. The culprit wasn't the peanuts themselves, but a super common mold growing on them, Aspergillus flavans. This led straight to the discovery of aflatoxin. If you picture Aspergillus flavans, it's often that kind of yellow-greenish mold you might see sometimes. And it turned out there wasn't just one aflatoxin. There are four main types, B1, B2, G1, and G2. They named them based on whether they glowed blue or green under UV light. Aflatoxin B1 is generally the most common and the most potent one.
And finding aflatoxins was huge news, wasn't it? Not just because they were toxic, but because researchers quickly discovered they were extremely potent carcinogens, at least in rats. And that immediately raised serious flags for human health. What made it even more worrying was the timing. This was right when organizations like UNICEF were promoting high-protein peanut meal to fight kwashiorkor, that's severe protein deficiency in kids in tropical countries. Suddenly, there was this awful possibility. Were efforts to save lives actually putting people at risk of liver damage or cancer down the line?
It absolutely raised that question, a major concern about widespread risk. Aspergillus flavus is just so common. It grows on many stored grains. It's even used deliberately in some Asian fermented foods. And what's more, if cows eat feed contaminated with aflatoxin, a derivative called aflatoxin M1 can end up in their milk. Plus, think about peanut butter, a staple food for so many kids. The toxicity is just off the charts. Like for ducklings, the LD50, the dose that kills half the population, is only about 0.3 milligrams per kilogram of body weight. Tiny amount. But maybe even scarier is a chronic poisoning. Long-term exposure to much, much lower levels can cause liver cancer. In lab studies, feeding rats just 0.015 parts per million, that's minuscule in their diet for 70 weeks, caused liver tumors in all of them. And if you connect that to human health, well, look at liver cancer rates globally. They're exceptionally high in parts of sub-Saharan Africa and the Far East, places like Uganda, Swaziland, Kenya, Thailand. And these are precisely the regions where staple diets are often significantly contaminated with aflatoxins. Now, obviously, we can't do experiments on humans to prove the link definitively, but the evidence, the correlation, is so strong it's considered almost a certainty. Kind of like the link between smoking and lung cancer.
Right. So what are we actually doing about it now? How do we control this?
Well, there's continuous monitoring and strict regulatory limits. Canada, for instance, sets the limit at 15 parts per billion in finished food products. Germany is even stricter at 10 ppb. But the ideal goal really is no detectable aflatoxin. And that comes down to things like proper storage, keeping things dry, and careful selection of nuts, especially peanuts, for human food, and sometimes diluting batches if there's slight contamination. Environmentally, Aspergillus flavus loves warm climates, and it's what we call zero tolerant, meaning it can grow even when there isn't much water available. We used to think of it mainly as a storage mold, something that grows after harvest. But now we know contamination can start right in the field, especially if insects damage the plants, giving the mold an entry point. We find serious aflatoxin contamination in peanuts, corn, Brazil nuts, milk, even wine sometimes. It's a wide range. This is largely why aflatoxin poisoning is more of a problem in warmer parts of the world. Interestingly, peanuts grown in cooler places, like Ontario and Canada, seem to be generally aflatoxin-free.
That's interesting. And you mentioned some innovation happening.
Yes, in Nigeria, which is pretty cool, corn farmers there are using a form of biological control. They actually spread spores of a different strain of Aspergillus flavus, one that doesn't produce aflatoxin. This non-toxic strain basically outcompetes the dangerous toxin-producing strain in the field, significantly reducing or even preventing contamination of the corn crop. Pretty clever.
Wow. From ancient plagues to these really insidious modern threats, mycotoxins have such a chilling reach. Okay, let's shift focus slightly. Our next stop takes us to places like Linshan in China. Here, communities faced another devastating health crisis, an incredibly high rate of esophageal cancer. And again, there was a hidden fungal connection.
Yeah, figuring out the cause in Linjiang was really complex. It took a lot of detective work. Initially, the suspicion fell on nitrosamines, which are known carcinogens, but gradually a picture emerged. People there traditionally boiled corn for hours, and this concentrated nitrates from the corn into the water, which they then used for soups. On top of that, the local soil was deficient in molybdenum. This meant the crops themselves tended to accumulate more nitrates, and their diet was generally low in vitamin C, which normally helps the body get rid of nitrates. Now, the poorest workers often ate steamed cornbread that was frequently moldy, and they actually said they liked the spicy flavor it developed. Researchers found that the fungi growing on this bread increased the levels of omis precursors to nitrosamines 17-fold. Lab tests showed rats fed nitrates and moldy bread got cancer. But here's the kicker. Even the control rats fed only the moldy bread also developed cancer. That pointed strongly towards unknown fungal carcinogens being involved. And the final piece of the puzzle. Doctors found living molds inside about 90% of surgically removed esophageal cancers and even in precancerous tissues.
Goodness. So once they've finally pieced all that together, what could they even do? How do you tackle something so deeply woven into diet and the environment?
It required a multi-pronged approach. They started treating seeds with molybdenum to fix the soil deficiency. They brought in piped water that was free of nitrates. They encouraged people to eat more fresh vegetables for the vitamin C. And crucially, they strongly advised everyone to strictly avoid eating any moldy food. We see some parallels, actually, with the Xhosa people in Transkei, South Africa. They also have very high rates of esophageal cancer linked to mold metabolites in their staple corn and traditional beer. They also seem to prefer moldy grain. In that case, the main suspect fungus is Fusarium verticilioides, and the specific mycotoxins involved are called fumonisins.
Okay, so beyond ergot, aflatoxins, and fumonisins, the fungal world seems to produce this just staggering variety of toxins, each with its own unique and often really terrifying impact. Let's maybe touch on a few more examples just to highlight this incredible diversity, maybe starting with some that affect the brain and nervous system.
It really is a broad spectrum. Take equine leukoencephalomalacia. It's often called hole-in-the-head disease, a truly horrible condition in horses, donkeys, mules. It starts subtly, maybe apathy, the tongue hanging out, they can't back up properly, start walking in circles. But it progresses rapidly to delirium, running into fences, violent thrashing, and then death, usually within hours or just a few days. And the name isn't just descriptive. Post-mortem exams literally show large, irregular holes in the brain's white matter where the tissue has just disintegrated. The cause, again, Fusarium verticilioides, that pinkish mold we mentioned growing on corn, and it produces those fumonisins. Outbreaks happen all over the world. Then you have mycotoxins that attack the blood and immune system, like the trichothecines. These cause a devastating syndrome called alimentary toxic aleukia, or ATA. This hit starving populations really hard in Siberia during and after World War II. People were desperate and ate grain that had overwintered in the fields, under the snow, and become toxic. The symptoms were dreadful. Nausea, vomiting, widespread hemorrhages, bleeding from the nose, throat bloody diarrhea, a dangerously low white blood cell count, which is a leukemia, leading to bone marrow exhaustion. Often, severe throat infections and necrosis followed, and many died from suffocation. The culprits here were other Fusarium species, like Fusarium poae and Fusarium sporchicioides, again, often pinkish molds. They produce a group of extremely poisonous mycotoxins called trichothecenes, specifically one called P2 toxin. You might also have heard about the yellow rain controversy during the Vietnam War. Reports describe chemical attacks with symptoms very similar to trichothecene poisoning, though it has to be said later analysis suggested many of those yellow deposits were actually just pollen clumps, basically bee faces, so that whole issue remains quite debated.
Wow. That's just a horrifying range of damage. And didn't you mention some mycotoxins can even act like hormones?
Indeed. Zearalenor, which also goes by F2 toxin, causes something called oestrogenic syndrome in pigs. It's also produced by Fusarium graminearum, often on moldy corn, just like vomitoxin. And it causes really striking symptoms, especially in young female pigs, gilts, swelling of the vulva, enlarged mammary glands and uterus, sometimes even rectal or vaginal prolapse. In young male pigs, you can see shriveled testes and enlarged mammary glands. And all these symptoms happen because zearalenone basically mimics estrogen, the female sex hormone. It binds to the same receptors. While it usually doesn't kill the pigs directly, it causes major reproductive problems, infertility, small litters, stillbirths. But here's another twist. In very, very low doses, these same hormonal properties are actually exploited. It's patented as a feed supplement to accelerate growth in cattle and sheep. We also see mycotoxins hitting the kidneys. Ochratoxin A, for example. It's made by Aspergillus ochraceus and Penicillium veridicatum, common molds often found on damp grain. It was first linked to a kidney disease, a nephropathy, in pigs back in Denmark in 1928. But crucially, there is a strong epidemiological link between this pig disease and a condition in humans called endemic Balkan nephropathy. This is a fatal kidney disease found in people living near the Danube River in parts of the Balkans. And thinking about common foods, patchoulin, this one was initially looked at as a potential antibiotic, but now it's a concern because it's toxic and possibly carcinogenic. It's produced by Penicillium expansum, the mold that causes blue mold rot in stored apples. So contamination of apple juice is something that needs constant monitoring.
It really is fascinating how these fungi seem to exploit such specific biological pathways in animals and humans, creating this incredibly diverse and often devastating range of effects: brain damage, blood disorders, kidney failure, reproductive chaos. So this brings up a really important question. Given how widespread these things are and how varied their effects, what are our actual strategies for dealing with them? How do we manage this risk?
Well, the absolute best strategy is prevention, and that mostly comes down to keeping things dry and cool. We even differentiate between field molds, which need higher moisture levels, maybe 20 to 25%, and storage molds, which can grow at lower levels, say 13 to 18%. And some Aspergillus species, as we mentioned, are extremely zero tolerant. They can grow even when things are quite dry. Temperature is also really key. The three main troublemaker genera Penicillium, Fusarium, Aspergillus, they all have different preferred temperature ranges. Knowing that helps predict where problems are most likely to occur. Beyond prevention, detection is absolutely vital for ongoing monitoring. It's tricky, though, because mold growth is often patchy, so getting a representative sample can be hard. The process usually involves extracting potential toxins with solvents, purifying them using techniques like column chromatography, and then separating and quantifying them using methods like thin layer chromatography, TLC, or, more commonly now, high-performance liquid chromatography, HPLC. Identifying them can sometimes be straightforward. Aflatoxins glow under UV light, for instance. Others need specific chemical reactions or tests. But the gold standard for really confirming the identity and quantity of a toxin is high-resolution mass spectroscopy, MS.
It's truly amazing, isn't it, the scientific ingenuity involved, all these complex steps just to accurately identify these tiny amounts of potent chemicals hidden in our food.
It really is. But even with the best prevention and detection, contamination does happen. So detoxification is another important area of research. Heat can help a bit. Mycotoxins are pretty heat stable, but heating, say, to 100 degrees C for a couple of hours can degrade a good portion of aflatoxin. Dry roasting nuts has a similar effect, but heat alone is rarely enough to completely eliminate the risk. Chemical treatments tend to be more effective for complete detoxification. Strong acids or bases can break down aflatoxins that's used for crude edible oils, for example. Ammonia treatment is quite effective for peanut meal and grains. It can almost eliminate aflatoxin, although it might slightly reduce the food's nutritional value. Other things like oxidizing agents, bleach or hydrogen peroxide, and even bisulfite, which is sometimes used as an antimicrobial food additive, show some promise too. So research is definitely ongoing.
Well, we've certainly covered a lot of ground today. It's been quite a journey, from the ancient horrors of ergotism limbs turning black, terrifying convulsions, to the modern discovery of aflatoxins, those invisible carcinogens threatening liver health. And then this whole array of other mycotoxins affecting everything from animal brains to reproduction to kidneys. It's undeniable that these fungal secondary metabolites are incredibly powerful and just, well, pervasive. But, it's also quite a testament to human ingenuity, isn't it, that we've developed such sophisticated ways to understand them, detect them, and start to mitigate their effects.
That's absolutely right. But it's also crucial to remember, despite all these scientific advances, many people, especially in less developed countries, and countless animals, both wild and domestic, still face very significant risks from mycotoxins every day. And leaves you with a provocative thought, perhaps. Maybe these mycotoxins aren't just accidental byproducts of fungal metabolism. Maybe they're actually an evolutionary advantage. Powerful chemical weapons, if you like, that help the fungi deter competitors or even destroy other organisms trying to get at the same food source.
That is a provocative thought. Survival of the fittest, fungal style. So maybe next time you glance at a loaf of bread or a field of corn, take a moment. Consider this intricate, often hidden world of fungi and their truly profound and sometimes terrifying impact on our lives and our history. It really makes you realize just how much more there is to learn about the unseen forces constantly shaping our health and the world all around us. Thank you so much for joining us on this deep dive.